Hey everybody, I just wanted to go over some of the notes for the next subject that we'll be doing some practice problems on. Let's take a look at it. This is for circular motion notes 2, centripetal acceleration and force. So a very interesting topic. So last time we looked at an object going around in a circle, like a tire, and we looked at angular velocity and how that relates to linear velocity. So now we're continuing with the spinning object, and we're learning about tangential velocity. An object undergoing circular motion has a velocity that is tangential to the circle. And I put the definition for tangent there, a straight line that touches a curve at one point. So anything that's tangent, anytime you hear the word tangent, so you have a circle, and if you go off in a straight line from that circle, instead of going in the circle, you go in a straight line, that's tangent. Right, so this line right here is tangent to the circle, the v, and that's the velocity we're talking about, which that is the linear velocity, right? Then we have centripetal acceleration. It is an inward force that causes an inward acceleration that bends the object's direction of motion towards the center of the circle. So you have this object, maybe it's a something on a string, like a ball on a string, you're spinning it around. Well, the ball wants to go in a straight line and wants to have a linear velocity. But we have the string and we're pulling it and in each direction, making it go in a circle. Well, that's the centripetal acceleration, and that's going to turn into a centripetal force. This is the formula for centripetal acceleration. The tangential speed, which is v, squared over the radius of the circle. Very simple. What is centripetal force? A force perpendicular to the motion causes the object to change its path from a line to a circle. That's so this acceleration is also a force once you multiply by mass. Right? Bigger the mass, bigger the force. So the bigger the ball, like if you have a tennis ball on a string, that's a lot easier, right? You don't need much of a centripetal force to keep it going, right? But if you have like a bowling ball on a rope and you're going like that, it's going to be harder, right? You need a bigger centripetal force to keep it going in a circle, and that's all this is. This formula. You take that same acceleration and multiply by mass, and you get the force. What is a centrifugal force? A force pushing away from the center. Now there is a little bit of not controversy, but misconception about centrifugal force. It's not actually something pushing you out. It's like the reaction force. It's considered like a false force because the car is experiencing is putting a reaction force on you. Same thing as the centripetal force. It's just the equal and opposite reaction. So that centripetal force that we were talking about, that's the reaction force when you're in a car and you feel it. You feel like you want to, go the opposite way of the curve. That is the reaction force of the centripetal force on you from the car, right? So remember we talked about Newton's laws. For every action, there's an equal and opposite reaction. The centrifugal, see this is it right here. The centrifugal force is not a real force. It is really the structure of the car forcing your body to redirect its motion into a curve rather than a straight line. So what does high G mean? High G, high gravity, is a tight radius turn at a high speed. So if you notice here, the larger your radius, the smaller the acceleration, right? How do I know that? Because they have an inverse relationship, right? The bigger the R, the smaller the A. If you have a small radius, so if you have a tight turn, you're going to get a larger acceleration, a larger force, and that's when you get into high G's, right? High gravity. So these jets going really fast and turning really fast, you can feel the force of the gravity, large gravity, high G's, when that happens. And that's it basically. Next time we'll do some practice problems. and yeah, do that stuff together. For now, I just wanted you to get familiar with the concepts and the formulas. Next time we'll do practice problems. Next time after spring breaks. Have a good spring break.